So we always get great speakers at the CHIME seminars, but certainly today we've got two extremely illustrious speakers. So it's hard to be more of a star in music and HCI than Nick Bryan-Kinns. He's a professor of interaction design at QMU. He's a Turing Fellow. He's a distinguished professor at Hunan University in China. He's created a wide range of commissioned pieces and exhibitions. He's won an order of magnitude more external funding than many eminent researchers can shake sticks at. He's been highly active in service to the discipline, running multiple networks, multiple DTPs, research grants, and platform grant, developed a range of UK-China partnerships. And he's supervised over 20 PhD students to completion, including several stars in their own right, with another 9 or so in the pipeline. But of course, none of that is the reason why we're interested here. The reason that we're interested is the sweep and detail of the research that he's led, spanning remote group improvisation, performative tangible interaction, extended reality, audience participation, and explainable AI in music. So without more ado, I'll hand over to Nick.
Well, thanks, Simon, for that introduction. Wow. Okay, I will share my screen now and try and follow the introduction. Let me see. Okay, is that good? Is that up? Yeah.
It's not quite full, but it's up. There it is, it's full.
Yeah, we don't need to worry about borders. Yeah. Okay, so I'll start my timer, make sure we're on time. Thanks again, Simon, for the invite and also the introduction. Yeah, so I'm going to talk today about explainable AI for music. And as Simon said, I'm Professor of Interaction Design at Queen Mary University of London, where I direct the Media Arts Technology Centre, and I'm a leader on the AI and Music Centre, which is directly relevant to this talk. And in total, in the Media Arts Technology Centre, now we've graduated over around 100 PhD students, and a lot of their work is in this sort of creative expression, a creative domain, and many of them looking at how you might use AI in creativity and the arts. So the work I'm going to talk about today, I'm just going to name check the students and researchers that worked on this with me. So Berke, Corey, Courtney, Yizhao, Jack, Bingwan, Song Yang, and now Ashley. So they've all been contributing to this work over the last couple of years, and some of them are now graduated from Queen Mary, some of them are still at Queen Mary. Jack is actually with 4 now, I think. So what I'm interested in, a little bit about me. So I'm really interested in new approaches to the creation and use of technologies in the arts and creative industries, and really think about how we can bring interaction design to that. And so in terms of artificial intelligence, my research really is at the intersection of AI and the HCI. And I'm really interested in how we design and evaluate interfaces between humans and AI in creative settings. So the key research question for me, the big picture, is how do people interact with AI in creative settings? And creative practice, especially live performance, live music performance, is really an excellent domain in which to research artificial intelligence, because it requires systems which are highly robust, responsible, reliable, trustworthy. We can't have a system that needs rebooting halfway through a concert, whether it's an audience of 2 or 2,000 people. So, you know, there's really a lot of tough design questions that go into this. And AI can now generate very complex and compelling music, by which I mean, you know, it can generate music, but I personally wouldn't say it makes music. But we could debate that for an whole hour if you like. But the point is that these, you know, the deep learning models are mostly or solely trained on content that was generated by people. So it's basically repurposing, mashing up, and pastiching human creativity and passing it off as a machine creativity, which, you know, again, we could have a discussion about that. Whether it is creative or not, AI, what I'm interested in is how we can design user interfaces to interact with our artificial intelligence in creative practice, how we can make these artificial intelligence systems more transparent and more understandable in a creative setting. And so what I'll talk about today, very briefly, I'll quickly mention artificial intelligence. I think we've already heard enough about that, probably all of us looking at the audience. Talk about human-centered AI, why that's important for the creative domain. talk a bit about explainable AI, and then focus on explainable AI in music, which is what the research is about. A explainable AI and music prototype, which we've been using to explore what it might be to design for that area, and then talk about some challenges, research challenges, and especially user experience design challenges, which actually connect with some of the things that Sheila was talking about. So very nicely connected set of talks, I think you'll see at the end. So artificial intelligence, I don't want to go into the background of this. The key point is that now we're in the third wave. There's really an opportunity for large-scale use of AI and thinking about the human-centered nature of AI. And so human-centered AI is really about amplifying rather than eroding human agency. And Ben Schneiderman's a big guy in this field who's written quite a lot about it. And so that's really what my angle is on it. It's really about computers should be playing a supportive role and amplifying people's ability to work in extraordinary ways, not replacing people and not reducing our agency and creativity. So as part of the human-centered AI larger field, there's an angle that I'm particularly interested in, which is about the explainability of AI. And this really looks at how we can make machine learning models, such as neural nets or deep learning models, which are incredibly complex and pretty much impossible for anybody to understand what's going on, how we can make those more understandable and more explainable to humans. And in 2016, Gunning sort of kicked off this term, thinking about how can we design AI that's more explainable, that will help us understand why did the AI do that? Why didn't it do something else? When does it succeed? When does it fail? And so on. And then explainable AI really has now become a hot topic in the HCI universe. And my question is, what might that mean? What might explainable AI mean for music? There's an exciting potential here for explainable AI for music, especially around co-creation. It seems like it'd be a great idea, right? If we could understand what the AI models were doing, maybe performers and audiences could get a better idea of what the creative AI is doing as it's generating music, why it's doing that, rather than just being a sort of mysterious box of tricks that generates music without us having any idea what's happening. But if we look at current creative AI models, there are very few which actually offer us humans any explanation of what they're doing or why they're doing it and so on. So to understand this better, we've been undertaking a survey of AI music papers. So we've surveyed 100 papers now, looking at the role that the AI had in the creative process and how much of the AI in these systems is actually explained in the system itself, not just the paper, right? So of course, there's several extremely thorough surveys of explainable AI systems, but they all focus on what I would call more functional tasks or explanations such as decision-making of why did the automated car drive in this way, or why did the medical diagnosis system make this diagnosis? There's no real surveys of how is explainable AI used in creative practice or creative settings. And the kind of metrics that people use are not really appropriate for creative settings. So we reviewed these 100 papers using a different set of lenses. We looked at the role of the AI from whether it is an assistant or a pen pal to a colleague or a coach, maybe. The possible interaction with the AI. So is it a static system that just generates content and we have no input to it? Or is it a dynamic system that's drawing information from its environment, but the humans don't interact with it? Or is it a fully dynamic interactive system where humans can interact with the AI and it generates content? And then how much common ground might we be able to establish or infer about the AI? What kind of cues to grounding might the AI be providing? So from whether there's no indication that's produced output to actually providing an explanation of what's going on. So let's have a look at what I'm talking about here. So there are some good examples of artificial intelligence which generate music with humans in an explainable way. So Shimon, the robotic marimba player, I think is a great example of some explainable AI. So it listens to live human players, it analyzes what they're doing in real time, and it plays along in a collaborative manner. But what's interesting is that as well as having the feedback loop, so it's a dynamic interactive system, it has some indication of what it's doing. So it nods along to the beat, it will sort of lean forward, it will change its body posture to indicate something's going to happen in the music, or that it's thinking or it's confused or whatever. So there's some sort of, beyond the music, some explanation of what it's doing, what it's thinking about, conveyed through the physical postures. And similarly, there's research in China, in Tsinghua University, where they have a robotic flute player, which does a similar thing where its body will move and orientate itself to indicate what it's doing in terms of the music production, and when it might come in and do an improvisation or a solo, or when it's taking a step back. So that's some way to indicate what's happening. Another classic example is the Hyperscore, which is from a few years ago. But in this one, you can start composing, and then AI system will add suggestions or add its own generated content. And what's interesting with Hyperscore is that it actually provides you examples that follow your input. So you get some idea of why it's done what it's done. It provides you alternatives and this kind of thing. So you could get a better idea of what the AI is doing, rather than it simply producing some sound without you having any idea how it did that based on your input. And of course, no talk about AI would be complete these days without a slide about ChatGPT. So I asked ChatGPT to write the chords for a song about slow-moving traffic in the style of David Bowie, which I thought would be quite a fun song. And of course, it came back with a nice song. It had some interesting, lyrics and some chords that sounded sort of David Bowie-ish. But what's interesting is when you then ask it to explain what it had done, why do you choose those chords? Oh, I choose those chords based on the style of David Bowie's music. And then it goes into this sort of, the way I think of it, like a music teacher explanation. It doesn't actually explain what it did as ChatGPT to generate this music. It explains from a music teacher kind of description of the music. So it's essentially a sort of a post hoc rationalization of what it did is what it's generating here, which I find quite interesting. Because in terms of explainability, it's not actually explaining what it did. It's explaining, as I said, post hoc, a rationalization about the music it made. So what did we find from our summary of our survey of 100 AI systems? Well, here's some results. So the orange one in these graphs, we can see that most of the AI role that systems took was that of essentially an assistant. So you basically say, generate this thing, it goes off and generates it. There's no interaction at all. There was a few that were pen pal, like ChatGPT essentially would be a pen pal. You say, make some music, and then it makes you some music, and then you say, oh, change the E minor to an E. I don't feel so sad today, please do that. Like a pen pal type thing. But hardly any of them became sort of interactive colleagues. Similarly, with the interaction, most of them were static in that there was no user input. There was very few that actually had dynamic user input. And in terms of the kinds of information that the systems were offering to help you ground your understanding what was going on, most of them were at stage one, which in our categorization means that really they just indicated that they'd made some music. You don't know what kind of output it is, where it's supposed to fit in the composition. They just generate a piece of, say, a jingle or a small melody, and you're supposed to get an idea what you do with it. So the point is here, 100 research papers, hardly any of them are doing anything super, interactive or providing very clear explanations of what they're doing. So there's a really great opportunity here, I think, to apply explainable AI across these kind of creative systems. And we could, that way, build AI systems that become more co-creative and more interactive with us. So given that there are very few explainable AI music systems and very few explainable AI systems for the arts in general, this means that we don't actually know what makes a good explainable AI for music. What kind of features should it have? How could explainable AI contribute to making AI more co-creative, more as a sort of co-creative partner with us? And then it's actually difficult to deploy explainable AI research directly into music for three reasons. The first is that most explainable AI research, as I said, focuses more on task-oriented AI models, such as why isn't AI 90% sure about something? Why did it do this classification? And so on. Secondly, well, explainable AI is quite new, so there's actually not that many papers that show you real systems. Mostly the explainable AI papers are theoretical, or they're more designs of explainable AI systems. And thirdly, most importantly maybe, do we really want to understand everything? So when we're making music, we usually rely on some sort of intuitive understanding of what's going on, if we're in a group improvisation setting, for example. But we don't have a sort of in-depth, explicit understanding of why each musician improvises the way that they do. We don't usually ask our fellow musicians about their rationale and motivation for every single note that they play whilst they're jamming. We're just interacting together. So why should we expect that kind of super detailed explanation from our creative AI systems? So that's kind of one of the philosophical challenges, right? How much explanation are we actually looking for in these creative settings? So given that we're a long way from being able to create explainable AI for music systems, we developed an early stage prototype, which is a first step towards more explainable AI for music that we're looking at. So what we're looking at is, in this one, how to make deep generative models more explainable, and in particular, how we make the latent spaces in AI models more understandable to humans. So I'm going to assume that most people know what latent spaces are, but basically, deep generative models frequently use these latent spaces to generate music. So the idea is that you train a model on a massive amount of data. It generates a latent space, which it can then generate music from in a similar style to the data that you trained it on. For our example, we build on the MeasureVAE architecture by Patty and Lurch, which can generate a measure of music similar to an example measure, as I just said, by encoding and decoding from the latent space. So we see the latent vector in the middle, so 256 dimensions. And in keeping with other research, we train the model using 20,000 monophonic Irish folk melodies. So it goes in the left. And this produces a latent space, which is a vector of 256 dimensions in the middle. And then from that, we can use that to generate new melodies through the decoder on the right. And the features of these new melodies could be varied by varying the values in the dimensions of the latent vector. So these kind of models have been successfully used for music generation, music inpainting between two pieces, music interpolation, that kind of thing, which is super great. But the way in which it works and modified is completely opaque to human beings, right? So you just cannot understand what's happening in that model. So to make the AI approach more understandable and explainable, we add a technique called latent space regularisation. And so this is a comparison. So this forces some specific dimensions of the latent space to represent specific musical attributes.
And will now be used. Alert.
So in this case, we map dimensions 0, 1, 2, and 3 to musical attributes of rhythmic complexity, note range, note density, and then average interval jump in the bottom diagram. And we just use these dimensions as typical musical metrics used in the research. So in this way, the latent space itself becomes more explainable because we've added meaningful labels to these 4 dimensions. And we can connect the inner details of the network to the outputs in a musically meaningful way. So let's have a quick look at this in action in our demo system. So we made a web app. Berka made a web app. Well, the team made a web app, actually, which you can see at this address if you want to. And so this takes an input MIDI on the left. And in the middle, you can see visualizations of the latent space, depending on pairs of metrics. And then you get an output on the right. So let's have a quick play of a demo. I do have a video with sound. I will turn the sound down because it was very loud before. Okay, let's see the demo. Okay. So that's our input melody, and then we generate output melody. So that's the same position in the latent space. Then we can navigate around the latent space to a different location. Here we're changing the note density. Or we could change, for example, the rhythmic complexity. Okay, So the key point here in this demo is that we can generate these short melodies in real time, and we can navigate through the latent space using these 2 pads in the middle. So in this way, we're modifying 4 musical parameters mapped into these 4 dimensions of the latent vector. So like I said, we can increase the pitch range, and the new musical measure is generated. So this increases the explainability of the AI, because key parts of the AI model are exposed to the user in the interface, and they're meaningfully labeled. So we don't just say, oh, you can navigate around this 256-dimensional space, which would be incomprehensible to people. We actually label it up with meaningful aspects and then meaningful metrics, and then visualize it. And the point is that the interaction that we develop, real-time interaction, allows users to explore the effects of these features on the generative music. And then in that way, they start to learn or intuitively get a grasp of how the AI works and how the different aspects of the latent dimension connect to the outputs. So is this enough? Is this an explainable system? Well, no, not really. I mean, it's got some nice elements to it, which is good, and it's the starting point. It's still kind of low explainability, right? It's more like an assistant or a pen pal. It's got some interaction. But what I'm interested in is, how do we increase the creative interaction with these kind of AIs? How do we expose the internal working of these AI models so that they become more of a colleague or even a coach in the interaction, and so that we can better understand what's happening? So this leads to a number of open research questions. So for example, when we're building these kind of systems, what kind of musical features are going to be appropriate to use? So the 4 that we used are pretty low level, right? And these are ones that we picked just because they are the ones that are most frequently used in the kind of music information retrieval. The things like rhythmic complexity or note range, if you go to a musician and say, hey, do you want an AI where you can change the note range of its output? They go, I don't really know why I would want to do that. So we need to be thinking more about what would be more sensible kind of metrics to be using here. Maybe we could be thinking about style or texture or emotional valence or something a bit more high level, which we could use to condition the dimensions in the latent space. Similarly, you'll notice that we used small measures or phrases of music. Is that a good granularity? Maybe it is for some things, but maybe other uses you want longer trains of music or chords or something like that. So really, we want to be looking at working with practicing musicians to understand better what that might be. Similarly, the AI models, we used a variational autoencoder. Is that a good approach? There's other approaches we could use. What would be better kinds of AI to use in these generative systems? We don't really know. We've got a paper at the moment, journal paper, where we compared the MeasureVAE to an adversarial VAE, so different kinds of ways of doing variational autoencoders, and seeing how that affected the interpretability and also the reliability of the metrics when we do the regularization. So it'd be super interesting to compare lots of different kinds of models and how we might apply or impose semantic meaning on parameters of those things. Similarly, for training sets, we use 20,000 Irish folk songs just because that's what most people do. But is that a sensible set of music to train an AI on? We did, in the journal paper, we then compared Irish folk to classical, pop, and Turkish folk music to see how that changed the interpretability of the metrics, how that changed the effectiveness of the AI system. So this is interesting areas to explain. As I said before, what is the nature of explanation in a musical setting? I really think it needs to be more a balance between super detailed explanation and something that's more like a gist. So you get an idea of what the AI is doing, and it's something that you can interact with and flow with in a creative setting, but it's not going to give you that super detailed, I made this 90% decision about a classification for this reason. Similarly, co-design of AI and then use in artistic practice. I'll show you a slide of the next. So we're currently deploying a version of this AI system in artistic practice to see how people respond to it. I think that would be quite interesting to get some results. And then finally, the user experience design. How do we actually design the interface? And I'll go on to that as the final wrap-up bit. So as I mentioned, we now got a plugin, Max for Live plugin, which we're starting to use in practice. So different musicians put it into their workflows, see how generating these small bits of music based on their music works. How is that used in music making practice? You know, is it a tool for inspiration, or is it more something that is giving suggestions or alternatives or whatever? How's that used in practice is what we're currently looking at. So I find that quite exciting, that bit. And then finally, just to connect up with the HCI theme, there's a lot of user experience design challenges, right, with this kind of interface. So if you think about it, we have, in our model, we have 4 semantically meaningful musical dimensions, right, out of 256. Imagine navigating a 256 dimensional space, right? That's mind-boggling. Even 4 dimensions is kind of crazy to try and navigate because, well, it's 3 dimensions plus 1, right? So how are you going to navigate that space? How are you actually going to do that in a semantically meaningful way? How are we going to make it interactive, learnable, intuitive, and at the same time, also surprising and engaging? Because often, you know, as a musician, you want to be surprised when you're making music. You don't want to think, oh, I'm just going to generate, I can predict what these things generate, because then I might as well do it myself. So you want it to be surprising and engaging, as well as learnable and intuitive. How do we design for that kind of setting? Tricky. So as I said, currently we've got 4 dimensions that we're exploring. Oh, we could just use sliders. It's kind of boring, not very easy to understand, not very good on the old explainability front. So as I said, we use these 2-dimensional plots. Starts to give you an idea of what's going on, but it's still, you have to really work at it to understand what's happening. Jack Armitage, who was working on this team, also built a version that is more in the aesthetic of contemporary music makers like live coders, that kind of thing. So that it would be interesting to see how that works. So mapping out all the different possible permutations of our 4 dimensions there. We could look at systems such as Google Magenta's inpainting. Maybe we could do it that way, so showing all the possible variations. The problem is this is not very explainable, right? I mean, how do you know what changing the latent space dimensions does to the music? So have to think about how that might work. So what I think is actually potential for interesting user experience design here would be more think about how can we employ more 3D visualizations, or think about how do we make higher dimensional visualizations of this kind of systems? How would we navigate those spaces? Are we going to use 3D input? Are we going to use tangible UIs like Sheila was talking about, or embodied control or something like that? So that's where I really think there would be some connection here between the embodied design and the research that Sheila was talking about before. But there is an issue here, just before I finish up, which is there's also a balance between, okay, I want it to be intuitive and I want to be able to understand it. I also want it to surprise me. But there's also a balance between the primary, you know, the navigation of the AI and the music making. So when we're making music, the main thing I want to be doing is making music, not fiddling around with the AI and moving the mouse around on the screen, all that kind of thing. So how do we create systems where we can navigate 4 or more dimensions of an AI, whilst at the same time, our primary task is actually making music and enjoying ourselves? So that is the big user experience design question. So maybe it'll be something more tangible. Actually, I noticed I almost have the same diagram in the bottom left that Sheila did in her slides as well, from her, I think that's probably Ishi's lab, right? Yeah. Okay, so that's my my talk. So yeah, I introduced a little bit about AI, why human-centered AI and explainable AI in particular is super important in the creative use of AI these days. A bit about my research on explainable AI and music and our explainable AI and music prototype, and how we want to use that to explore design and better use of the user experience. So really, from my perspective, it's about thinking about that. How do you convey the gist of what the AI is doing in a creative setting? That's really the balance that we need to get to in terms of both visualization, user experience design, and the explainability of the AI. Okay, thanks so much. Looking forward to any questions.
And so please do indeed post your questions to the chat. Oh, and we got hands up straight away. Well, the one I saw first was JP Carrascal. Oh, lots of questions. JP, do you want to?
Might be the applause symbol rather than the raise hand.
Oh, I'm sorry, I'm an idiot. Yes,
I'm sorry.
okay. All right, sorry, my mistake. Okay, well, let me jump in with a chair's question while people are formulating things. Okay, this is kind of a detail, but I love this question of navigating while making music. You know, how do you make that congenial? And I wondered if you'd seen things like Juan Martinez Avila's thesis, where he'd applied SOMA interaction design to precisely the problem of encumbered design, and whether you think that might have any relevance to that problem.
Yeah, I think that sounds a really good approach. Yeah, the SOMA design approach. I'm not sure I know the paper directly, but I think I've heard about it. But yeah, that whole idea of thinking more about the bodily interaction and the physical interaction, taking the somatic view on it, I think has got a lot of potential there in terms of how do we design these systems that are more richer forms of interaction than just sitting staring at a screen. Yeah.
And just while people are thinking about, oh no, we've got a hand up. There we go. That's Francisco, I think.
Hi. Can you hear me?
Yep.
Well, hi, Nick. Thank you for the talk. Really interesting. There was one specific part that triggered my curiosity, which was about how the labels were applied to the latent variables of the latent space. So because that's an unsupervised training process, so you use an autoencoder, could be again as well the same thing. So there's no intervention of the human to generate those variables or dimensions. Well, they're basically extracted from the structure of the information.
Yeah.
So I was wondering, how, as a designer, do you think that people can deal with the ambiguity that might, well, characterize such dimensions? Because some of those dimensions, sometimes, if you tweak them, if you use them as a synthesis parameter, they might just feel that you're affecting many parameters at the same time. So as a designer, how do you deal with the ambiguity of the semantics that were assigned, like, primarily on that level? And
yeah. So that is a really great question, and that's why I was saying that, you know, in our first you know, iteration of the prototype, using these 4 parameters is fine if you want to write an academic paper and say, oh, you know, we use these 4 parameters because everybody else did. But as soon as you start trying to use it in music making practice, the dimensions are, although they're quite separated, they're still entangled to some extent, as you say, exactly right. So
exactly,
no density and rhythmic complexity are naturally going to have some strong relationship. And so that is why I think it's important for us to be doing research where we take all these systems. You know, there's new AI systems generated every day, right? Created every day. So we really need to be reflecting more on what are these metrics that we're using, how, or these attributes that we're using, musical attributes. What are these musical attributes that we're using? Are they actually relevant to music making practice? Do they actually make sense to musicians? Well, probably not, but what would make sense, right? So I think that's a big challenge. And I think that's where we need to be doing more co-design with musicians and artists when we're thinking about these creative systems. And to do that kind of co-design, you know, we don't need to be creating another 100 new AI models. We can use the ones we got. They already generate stuff that is quite reasonable sort of output. What we need to know is how do we control them better?
Maybe using symbolic models in articulation with those models.
Yeah.
Something that's more symbolic, or okay. Oh,
yeah. So I mean, yeah, it'd be interesting to compare different kinds of generative algorithm, like the more probabilistic ones. You know, they're nice because they're easier to understand, but then the output is more typically less amount of novelty in it. So the fun thing about the deep learning ones is that you tend to get more elements of novelty or surprise, but still within the genre, if that makes sense, or the style that you trained it on. And as a musician, when I'm using these AI things, which we've started to do as part of our research, it really is, you know, I could get an AI to suggest a fill or something, but that's not really what I want to use it for. I want to use it as inspiration, get something different, and make me surprised and delighted by it, not just, oh, that's nice, you filled in the bridge here, thanks. You know, so I think it's a tricky balance, and we haven't got enough human-centered research on it yet.
Thank you.
So JP did have his hand up. I'm hoping he hasn't changed his mind.
I just was trying to come up with some question, but I'm not really sure if it's going to make sense. So yesterday, first of all, thanks very much for this talk. Was super interesting, Nick. Yesterday I attended this other presentation about the argument was that AI would essentially bring an end to the computer science discipline. Because what we've done since the beginning of the computer science discipline is using computer languages to tell computers what to do. And the argument was that these computer languages are highly imperfect and they're complicated. Like we've been trying to do this in a simple way, but there's no simple way to do this until now. And now we might switch to might be close to realize this dream of being able to tell computers what to do in natural language. So essentially it's this might replace the way that we tell machines how to behave. Is on top of augmenting our capabilities, is also changing and replacing some of the essential things that we are used to, how we are used to behave and work. So my question, and again, I don't know if it's going to make sense, but do you think we're going to be using AI to replace? We've been talking about augmenting mostly, I think, like creating compositions using AI to augmenting our composition skills, but do you think AI might also be used to replace the way that we do some musical tasks or maybe sound production tasks?
Yeah, I think for sure. I mean, already it replaces some production tasks, right? Like you can do automatic mixing, automatic feedback removal, this kind of thing. That's great use for it. And the way I see it is that, how can I say, music composition to brief, let's put it that way, like that, you know, people who write advert jingles or who write background music or whatever it is, or scores for movies. Yeah, for sure. Next year, will there be any people doing that job? I don't know, because you can go to an AI and say, "Hey, make me a jingle that sounds like soap bubbles, shiny soap bubbles, please," and it will go and do that, right? No problem. And then you don't have to pay the musician to do it, and you don't have to pay the rights and blah 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 every time you show the advert. So that one of the challenges there is that for many musicians, that's a big source of income, right? Writing music for background music for TV shows or adverts or movies or even radio shows, that kind of stuff. And once that goes, that's a big source of revenue that's lost or taken away. It's not lost, is it? It's taken away from musicians where are they going to get the income from there? So yeah, definitely those kind of tasks where it's composition to a brief. I think that is going to go pretty quick. Yeah.
And sorry, you carry on.
May I ask a follow-up question?
Please.
Just would love to hear your thoughts on. So you're talking a very complicated social impact of AI and economic impact. So I was wondering, what's your perspective of what researchers and of course I know that the company should be doing a lot of this, but what should researchers do to try to be more aware or try to mitigate the negative consequences of introducing AI in all these disciplines like music?
So I think for me, the mitigation from a research side is keeping access to AI open, right, and available. So the issue that we have at the moment, in my view, with these generative models like ChatGPT or whatever, is that the control of these AI systems is getting consolidated into 4 major companies who are basically doing it for their own corporate gain as a market grab. And because they are controlling all this sort of large language model generative technology, especially the more effective versions, because they have the biggest data sets, they have the biggest data centers and computers to use. There's a risk there that all of this generative products are owned by the 4 major companies like Microsoft, Google, Facebook, and whatever the other one is. I can't think of. Maybe it's IBM. Anyway, so that's the risk, right? And so what can researchers do about that? Well, continue to push research which creates more open, freely accessible, and understandable, explainable models that other people can use and manipulate in ways that they want to do in their practice. Yeah, that would be my view.
Thank you.
So Jesse's had his hand up for a while. Jesse?
So kind of going back to that, the labeling of one of the cells in the vector, in the latent vector, and being able to quantify that or explain it, I suppose is the best term, as like rhythmic complexity.
Yeah.
I found that even though you can label it, I haven't been able to, the value changes don't seem to be very, very linear. So a change from 0.1 to 0.11 may be as drastic as 0.1 to 0.8. And I'm just kind of curious if you've got some strategies for kind of getting around that or trying to make it, because it seems like that's the last or the next connection that we need to have to be able to make it not just explainable, but usable. I'm just curious if you've got thoughts on that.
Yeah, so we haven't explored that level of detail yet. I had noticed that as I will call it a feature of the system. You could call it a problem. But yeah, it does do that. And that's partly what the visualization shows. So some of the 2D plots show that a lot of the yellow bits are sort of bunched up at one corner or one end, which means that when you get to that point, you've got lots and lots of things suddenly changing at that sort of right-hand point, and not very much changing on the left-hand side. So you do get that problem with a sort of non-linearity of the regularizations of the dimensions. And how to address that, I don't know. I mean, I think that's one of the challenges, around partly working on better regularization methods, but also thinking more about what kind of things are we trying to capture in those attributes, right? So 2 sides to it. And partly it's also to do with the data sets used, right? So partly it's due to the nature of Irish folk music, where there happens to be quite a bit of variety of rhythmic complexity actually compared to, for example, if we trained it on pop music, we'd get probably a smoother amount of change across rhythmic complexity, because the style of pop music is much less rhythmically complex than is found in Irish folk music. So there's a couple of things there, but yeah, it's a good point. And that's exactly the kind of thing that I think would be interesting research to actually undertake with musicians and with looking across a range of data sets and different kinds of models to see what gives you better or more usable results. Yeah.
Well, I think pretty soon we should be taking a quick comfort break and then return for anyone who wants to return for a longer, wider discussion. But just very quickly, there's a question that's been waiting in the chat from Konstantinos. I don't know if you clocked that one. Nick, any details about the live coding?
The one that says, so that one was the interface that Jack Armitage made. So I think live coding was the wrong word to use for that genre. What I meant was more like electronica, sort of Ableton Live type aesthetic that we were going for. So my point was more that we've been trying designing interfaces that original interface looks very much like a web-based interface that an academic research team would make. And so we very much wanted to explore making interfaces that would be more suited to different, in the wild practice. So the Ableton aesthetic, or the plugin aesthetic, that kind of thing, to make it sort of fit together. So I think that was my mistake in the talk. It's not live coding, it's just more the aesthetic of the Ableton Live type visuals.